Okay, let's continue the issue of CPP09 proxy option. Let me get my window back. So we have cover the what's the basic concept about shadow object is essentially hiding all the detail regarding where exactly the real object is, while the um, the um, the client program, they can just interact with a local representative about this object. So in this example, let's actually just recap this a little bit. Go back to the client.cpp. This is important, is that I try to hide the detail under the shadow object, but it's also very important. I have to put the shadow reference into another object called label GPS PTR. And the label GPS PTR could be pointing to shadow one, and it could be pointing to a real object. It could be pointing to a shadow two. So as an application programmer, I should not directly interact with shadow or directly interact with the real or directly into with shadow two. Instead, I should just focus on how I should interact with this object called label GPS star. Okay, I mean, all of them supporting the interface of label GPS star, and therefore I can just interact with that object and have this part over here. Okay, so that's essentially what we try to telling you is that what is the role of a programmer without worry about exactly where that resource is. Okay, so now we want to see that if this object is actually remote, then how do we implement the shadow object so we can actually leverage the shadow object to access that remote object? So that's why we're going to look at this code. And because now to do remote procedure call is the responsibility of the shadow object, and such that not shadow GPS.h, but inside the shadow underscore GPS.cpp, which is a separate uh, function or the scope in such that I can actually implement those mechanisms. The other part, which I didn't realize, is until the last lecture, I can actually remove everything about JSON RPC from that PO client.cpp, such that the programmer doesn't even need to know what is JSON RPC. This is convenient. You don't need to learn. You don't need to know that, and then you start interacting with the object. But the object is actually remote using JSON RPC. So that's another advantage that you can start writing program without even explicitly knowing what JSON RPC is. But somebody else is going to write this code called shadow GPS.cpp will handle that part of the complexity for you. Okay, that's the important lesson to learn as well. So now I want to actually look at this function called dump to JSON. Okay, dump to JSON is a function that's inside shadow GPS.cpp. But the implementation of this function dump to JSON under shadow GPS is quite different from the dump to JSON in all other functions, such as GPS.cpp or label GPS.cpp. Let me just contrast what you have in label GPS.cpp. If you go to dump to JSON, it's actually about calling the base class dump to JSON and then set the result label to be whatever label it is, and then basically return the result. So that's the real JSON programming over there. But In shadow GPS, it's nothing to do with those. It's only worry about locality, about this object. So what it does is it now you see that I kind of move those three line. Those three line, if you remember, let's just contrast this two a little bit. I would say RO client CPP. Okay, this is the RO client CPP, and the first view line is looks like this, right? Remember that? It looks like this. But now with the PO client.cpp, we no longer have those three lines, but there's nothing magic about it. Because why? Because we move it under the member function of the shadow object. So essentially, you see that we kind of move that functionality into another class. The implementation of the class is called shadow GPS, and such that we hide the detail and let the programmer worry less in that process. Okay, so I have to deal with this, but then remember when I initialize a shadow, I have to have a URL. I have to have the class ID, object ID, and the URL is used here, host URL. I have to use the host URL. Let me actually repeat that again. So over here, you see that my HTTP client, the URL is hard coded over here. I basically need to write down exactly what I need to do. But over here inside, the shadow GPS is actually being parameterized. So whatever you set the dump to JSON, oh, sorry, the shadow GPS, whatever you set it up, then that URL is going to be go over here, which is now we can contrast. Over here, when I create the shadow object at this moment, you see that I actually include the URL as one of the argument to configure the shadow object to pointing at that particular location. By the way, this is interesting. The difference, you might think this is no difference, but the advantage of doing this is that I can change the URL. Assuming this URL change a location from location 1 to location 2, then I can actually just modify this argument and the rest of my code are still the same. I mean, it's still basically looking for whatever the latest value of the host URL attribute. And then that's where I'm going to contact. Okay. Okay, so I have to set the URL. I have to call the PO client, my client, which is that's the JSON RPC business to set up the protocol, and then I have the result. And then look at what I did. I'm still doing the same thing. My client dot dump to JSON, and then I'm actually calling the class ID and object ID. Okay, that's essentially very similar to RO client, the way RO client conduct a remote procedure call into another real object on the other server. But instead, I kind of remove that operation and put it into the shadow objects member function. And then dump to JSON, you have to use this. And then we can look at set GPS label. It's the same concept. I still have this first three line. I'm still doing this. So if you look at this, this is really a template. It's really a template for us to basically create every single member function that would like to support through remote procedure call, and then I'd be able to do this way. Okay. All right. So let's take a look at the other side. So in fact, the shadow object, the interesting part is really the shadow GPS.cpp. The client and server, they are basically either less complicated or about the same, the server side, like ro.cpp. Okay, let's actually take a look at this. Let me first, I still have this JSON file, which is called EC36B PO.json. If you look at this, I'm still doing exactly the same. By the way, this file is should be identical to the same JSON RPC configuration file as we did RO CPP08. CPP08, from this perspective, they should be identical. Okay, now let's look at the PO server. Okay, this part should be identical. I still have this object 1001 pointer, and I still have my PO server, but just change the name from my RO server to my PO server. Okay, and then I still have this constructor and two member function from the server side. And inside here, I still have this function. So essentially, this part is identical because the proxy object is really the proxy is on the client side, is not on the server side. The server is always the real object they need to communicate with. So the server has to call object 1001 w2json, and where is object 1001 is actually under here, new label GPS. And just still listen to port 8300 or whatever port you want to choose, and then start listening as we indicate last time. Okay, so that's how we let the server side. So now let's actually go back to the client side a little bit more. Okay, so let me go over this to let you know now it's a template, so I want to convey this a little bit slowly to talk about how do you implement the shadow from the a member function like a dump to JSON. So what you need to see is the first one you need to set up step one, the first part of your program is essentially set up the HTTP and the client using the this two line. I mean, you've seen these two lines are always there. If you want to do remote procedure call related to JSON RPC, okay? And then this part is the result. The rest is just set up the call. Okay, and then it's basically just set up to using a try clause to be able to handle the whatever the RPC related stuff. Okay, okay, it looks like that, just this two part. But I want to yeah, I know what I want to do next. I want to start move into a little bit about exceptional handling. So if I compile everything, let me just make a clean again. Okay, and I'm going to run the server. I'm going to run the client. Okay, everything looks okay, right? Okay, so now I'm going to kill the server. I want to run the client again. Okay, now you see there is something called exception minus 32003 client connection error. So essentially, there is an exception being generated, and it's not being is cannot be connected. So there must be some part of the code is capturing this. So let's take a look where how this actually happened. So let's first go to the PO client.cpp. Okay, you see that there is a one particular place that has this try clause and catch as a standard exception. So I'm actually going to print a message over here. I would say print F. I am in PO client dot CPP. I'll show you why I did this. Okay, and then I'm going to do the same thing here. So meaning that if I actually see the message I am in PO client.cpp, then I will know that this particular portion of the code, exceptional handling code, has been captured. Okay, you probably have no idea why exceptional handling, but I want to start giving you the example that how those message that you saw error message were produced. Exactly, at least you know where it was being handled. Okay, now my server is still down, and I'm actually going to run the client. Okay, so now you see that I actually have this two arrow message, but you didn't see the line says that I am in PO client.cpp. So that means they must be in somewhere else. Okay, so now let's take a look. Let's modify this time. Let's go to yeah, shadow gps.cpp. Over here, I'm going to do printf. I am in shadow gps.cpp. Okay, for each of the function I put it here, maybe I just put two more to just explicit. I'm saying I'm in dump to JSON shadow gps.cpp. Over here, I'm actually going to say I'm in set GPS label shadow GPS. So you can do the same thing to modify to verify how the program where certain information was handled by which part of your code. So let's try to compile, and then I try to run the code again. Now you see that the first exception is actually in the set GPS label exceptional handler. So I must first call set GPS label in my client program. And then the second one is I'm actually in dump to JSON. Okay, so that's good. Okay, but I want to actually do a little bit tricks to just tell you that the difference, you will know why. You will learn about this. Let's see if I can do this. Okay, by the way, I don't know whether this will work, but I'm going to try it anyway. I'm going to catch, except I'm going to catch using a different class. I'm using std exception. Okay, I think that's fine. And I'm going to do this also with, no, I'm just modify one. I'm not going to modify two, just modify one. Let's see if it's going to create any difference. Okay, I'm still catching it. I'm still catching it. Even I changed to uh, um, STD exception. The result is as I expected. But I want to tell you what I just did here. What I did here is that I modify instead of catching the JSON RPC exception, I actually catching the standard exception. The reason I this will work is that STD exception is actually the base class for JSON RPC exception. So I'm actually catching something which is at the base level, which is fine. Then it still work. I can still catch it. Okay, so just try to tell you this is what I did. Okay, let me actually comment this out. Okay, so that's so far so good. We have all the things that's as we needed. Okay, I hope you don't have any question, but if you have a question, ask me next Monday. So now the next thing I want to do is that now I want to play this trick. Ah, I know what happened. Remember I said I have this shadow GPS. There was another version which has a function called public GPS DD. Okay, so I have a two way of creating the shadow GPS. It's referring to this particular slide, not this particular slide, but this particular slide. I mean, where should I put shadow GPS? Either I can put it here, I can put it here. What's the difference? So let me try to handle that right now. So if I do this instead of this, then I in fact I can just do this, okay, without going through the without modify this line, okay? But just modify this is enough to create the difference over here. So if I let the shadow GPS inherit from GPS, then wait a minute. It should be okay. Okay, that might be a good idea. Okay, I'm going to do this. In fact, I think I can do this as well. Okay, let me try to compile first. Yeah, I can still do this. It doesn't matter. Okay, it basically give me an arrow when I try to compile the PO client because I'm actually trying to convert. I'm actually trying to do some kind of conversion. Let me see if I can get this part to work. How do I get this part to work? Oh, okay. I know what I can do. That's interesting. I mean C++ is a dangerous language. I believe I can do a lot of trick. So the error message is this line. See that is this line. Okay, I'm going to do casting. Okay, so you see, I had that error message because it says that this one is a shadow GPS pointer, but this one is labeled GPS pointer. And remember, right now, since I make that modification, the inheritance hierarchy now looks like, now I have to move this out. It actually looks like this. So they're not, so shadow GPS and label GPS, they're not directly. They're not directly based and derived. Okay, they're parallel. They're in the same level. But I can still do this. Let me actually see if the compiler now will let me do this. By the way, when I said this, you probably have the feeling I have done something similar before and the compiler allowed me, but I'm always not sure. I always have to done it now to actually demonstrate it works. Okay, you should do the same thing for any kind of programming. Okay, so I'm going to add this label GPS star. Let me try to make clean and make. Now let me do it. You see that over here, when I did this without the casting, it basically gave me an arrow, not just a warning. They gave me an arrow saying that, hey, you shouldn't mess up with this. But then, well, fine. If you want to see that, I just casting. I cast two from one data type to the other data type. They are not even base and derived. They're in parallel. I can still do this. Compiler still let me to do this. Let me actually try to run the program. Just run the program without the server first. Okay, I'm actually getting exactly the same stuff. But now I'm running the server and I run this. It's fine. It's actually talking to, by the way, if you see this, clear is actually getting the accurate result. So the shadow, in this case, I can actually set it up under GPS or under label GPS. It's okay. Either way is fine, and the program will work, but you need to do some casting. Okay. So this sounds good, but then there is a one extra issue you should know is I play a trick. I play a trick in this sense. Most of you probably didn't realize that there was a one trick I did, which is kind of ugly, but I have to be honest with you, it's probably better to to make this one under here. It's probably better to make it under here, such that I have an inheritance relationship. And this one maybe is not a terrible good idea. Uh, it doesn't allow me to move around like this. Anyway, okay, I will explain to you why this is actually a better design in this particular case. But it's not perfect. You have to think about this, judge yourself about which way you think is better. Okay, I'm going to tell you what's going on. First, I want to say what's the main difference between GPS and label GPS. The main difference is this. Ah, this piece of code is ugly. Okay, the reason I did this is because I was doing memory layout, which I kind of regret to actually messed up with this over here. Okay, but anyway, I have two member function. One is set GPS label, one is dump to JSON. They're both virtual function. And inside GPS, I only have one virtual function, which is dump to JSON. Okay, this is the only virtual function I have. The rest of this, don't worry about that. That's actually put it there because I want to show the memory layout for inheritance hierarchy and multiple inheritance and single inheritance. So don't worry about those two lines. But the core thing, the core difference is I don't have set GPS label from the GPS class. It's only available from label GPS. But now we do this. The trick I play is even though shadow GPS in this case, I inherit from GPS DD, but it still have set label, set GPS label. So essentially, I kind of manually add this particular function inside the shadow GPS. The reason I cannot avoid that is because I want to support a proxy object for label GPS. And for label GPS in the proxy, one of the member function is set GPS label. And therefore, there's no way I have to implement that particular shadow code. That's why inside this set GPS label, I have to have this part. Because if I don't have set GPS label, that means I don't have the 3 lines of code. And then I cannot actually contact a labeled GPS object on the other machine. And then therefore I have to encode this part. So in order to make it cleaner, I think the better way is actually using this instead of doing the directly inheriting. And doing this, everything is very clean. Conceptually, you know, okay, you want to do label GPS. I even think that you can actually call the shadow label GPS because you might have another shadow something. Okay, if GPS has another derived class, for each of the derived class, you need to create a shadow in this sense. Okay, but in this example, I'm going to get rid of this. So you can see there are multiple ways for you to handle this, and it's quite interesting. Okay. Okay, any question? Okay, now I want to tell you a little bit, since in this example, there's one more thing which is important, which is inside of, sorry, inside label gps.h. I actually did some trick here. I don't know why I put it here. It's interesting. I talk about operator overloading. Um, you see that I operator overloading the bracket. This is purely for fun. Okay, this is purely for fun. It's just showing you that well, you can actually operate. You can overloading pretty much anything with any data type. So I overload bracket for label such that the argument inside of the operator bracket is going to be a double. Okay, so essentially I allow you to do something. So let's take a look at the code. This is doesn't make sense. It's just for fun. Okay, but I feel it's a good learning experience since I put it here. Inside this label GPS, you can see I have this function operator. And then I have a double, which is my latitude. I actually allow somebody to put a uh, a um, um, uh, double a floating point inside as the argument, and such that I actually set a JSON value, which is set the only has a latitude, which is a JV latitude, is equal to whatever number you just put it in. And then return JV. Okay, so I kind of create so your program will looks really weird. Okay, so with this operator overloading, now let's take a look at PO client. So the code is inside here. By the way, I probably don't need this casting. Let me fix this. Let me just label this is for different inheritance. Okay, and I'm getting rid of this. Okay, this should be fine. And now you can see what I did here. This part is I set a JSON value result one and real one. What's real one? Real one is a real GPS. Real one is Costco Woodland, okay, with the GPS location over there. And then what I did is real one 1.23, which means that the latitude value going to be displayed is 1.23. Let's actually make it 7.77 instead. Okay, and then I print the result. Make it. Okay, and then I'm going to, the server is still up, so I'm going to run the client. Okay, you can see that this is, oh, this is interesting. I said 7.77, but somehow it's a double precision, somehow very interesting. This is, I believe, is a bug of either C++ or JSON CPP, such that it convert my number into something which is sorry, something which is a little bit less than 7.77. Okay, that's interesting, but it's operator overloading. Okay. Okay, the next I'm going to talk about, I think I'm going to first talk about exceptional handling. And then after I finish exceptional handling, then I'm going to go back to talk about the difference between multiple inheritance and virtual inheritance, and what's the difference between these two. I mean, this part of the lecture is really just telling you, discourage you to do certain things. But the good thing is learning there is something called vtable pointer inside the object. There is a few very interesting pointer called vtable pointer, which is pointing to other part of resources, such as virtual function implementation. Okay. Okay, I'm going to skip this part, directly go to exception. Let me see, where's my exception? Lecture, it must be lecture number 8. Let me bring it up to lecture number 8. Yes, okay. So now I'm going to tell you, you have seen this. So I want to start to give you some basic syntax about the exceptional handling in C++. Um, so it typically have two pair of curly bracket with three different keyword. One keyword is called try and catch. So try means that you have some part of the code that you would like to be protected by the exceptional handling mechanism. And then you have a catch clause over here, which is if something happened, then it will derive the program control from the try clause to catch. So let's make a example. Is you try to do something, and in the middle you realize that there is error condition. There are certain error condition. By the way, not all error condition can be handled by exceptional handling, which we will show you example that why sometimes there is certain thing is uncatchable. Okay. And therefore, like, oh, I know what I want to do. Okay, what is uncatchable? Can I make it uncatchable? Oh yeah, I can make it uncatchable. Okay, let me do this. Let me see if this works. Let's go to label GPS. Where's my code? Let me inside shadow. GPS.cpp inside this part, set GPS label. I'm going to do something a little bit weird. I say throw. I create, maybe I just say GPS DD. Okay, fine. That's fine. GPS. Can I do this? GPS DD is fine. Star. Uh, GPS. PTR is equal to new GPS DD. Can I do this? Okay, fine. Throw star GPS PTR. So I'm actually trying to throw something which is not an exception, it is actually throw a GPS DD object. Let me see if this can compile. I think it can, but I want to just make sure. Okay, it looks like it's okay. Let me just okay, so I actually throw a GPS object, and now I'm going to kill my server. In fact, it doesn't matter. Okay, in this case, I can run the server still causing the exception. So now I'm going to run the code. Okay, look at this. It says the program terminated. And look at the error message. It's terminating due to uncaught exception of the type GPSDD. Okay, it's uncaught. And then it has this trap called abort trap 6. So when you do exceptional handling, if you actually see this kind of abort trap 6, or you see this uncaught exception, that usually indicate you have generate an exception condition is incompatible with your capturing mechanism. Okay, so what's the capturing mechanism? Sorry, if you go to shadow GPS.cpp, your catching is try to catch, no, I'm looking at this part. It's try to catch JSON RPC exception. It's trying to catch this particular GPS, sorry, this particular exception type, but you're throwing an exceptional condition that's using GPSDD, which is totally different exception type, and therefore it's uncaught. That's why you will see that abort trap 6. Okay, and that's why sometimes you see that it's something uncatchable. So essentially, let's go back to this. So we have the try clause, we have a catch clause, we have a throw clause. So throw is the trigger of a some kind of condition you want the catch clause to catch. Okay, so for example, if you throw an exception, let's actually go back to I'll forget it. I will do that later. If you generate, say, a JSON RPC exception, or you actually generate a standard exception, then the catch exception should be able to catch it. And then essentially you transfer your control from the throw point into the catch point. Okay, that's what happened. Okay, so now I want to show you a slightly more complicated example. Let me actually use this slide. So essentially what we're doing is essentially if okay, if this is your program, you kind of determine at some point you should not continue with this execution because it's going to causing problem, and then you need to kind of jump out in this case. Okay, and then this is another example about exceptional handling, and sometimes you have a different type. For example, Over here, I throw a string. Over here, I throw an integer. So one is throw, not throw exception, but instead throw a string or throw an integer. So I could have a two catch clause. So I have a one try clause. I have a two catch clause, one catch integer, and one catch string. So if you execute the program, if you actually encounter this condition, then it will transfer over here. But if you encounter this condition, it will actually go over here. Okay, so basically it can do this. Uh, and the other thing, which I think is interesting, I want to show. Oh, okay, this is a code is interesting. Um, by the way, you didn't see any try clause over here. But over here, you try to create some kind of object, and inside the code, they might generate exception. And then, so essentially, when you call the new, inside the new, it actually generate some kind of system exception. But you still need to use exception at the higher level to actually do that. I know what's the example I want to show you. I want to go back to this example. This is the last example I'm going to do, then we're going to see you on Monday. So remember I said if I have this throw GPS DD, I cannot catch the exception, it become abort trap 6. But I can do this. If you notice what I did over here in the PO CPP. If you remember what I did here, when I call set GPS label, I have a try clause. I have a try clause here, and over here I have a set GPS label. And over here, when I try to catch, I catch standard exception. But now I'm going to change it to say, hey, I catch, I believe I can do this, GPS DD. I catch this object and I say I'm in PO client GPS DD exception. Okay, let's see if this works. So let me try to run the program again. As now, if I run this program, I'm actually going to get this abort trap 6. So now I didn't modify the shadow GPS CPP, but I modify the higher level, which is the PO client.cpp. Let's try to see. Oh, I cannot do. Okay, that's fine. That's fine. I know what this arrow is. Because that was a what function, was a standard exception. What? Okay, I'm going to modify this. I'm going to just comment this out because I cannot do this because of what is a member function. I have to have that for exception, but that's not for GPSCD. That's why this won't work. Okay, now it works. Now I'm actually running the code, PO client. Now you see it's fine. It's actually running because what? My exception, you see, where's my exception? You see that? This line, it print out. It says I'm in PO client.cpp GPS exception. So think about what happened. Let me actually tell you the code. I'm going to write down the code this way. I'm going to insert a slide. Get rid of this and get rid of this. So first, I have a function called shadow GPS, colon, set GPS label, whatever. And inside here, I have a try clause. And inside here, I have a throw GPS DD, kind of like this. And then I have a catch clause. But the catch clause, the data type of catch clause is JSON RPC exception E. And then I have this. Okay, so I should probably say there's a dot 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 over here. There are certain part of the code is over here. Okay, this was the code. I kind of pseudo code represent what we just did for set GPS label, try, throw, whatever. And the thing is that if I only have this part of the code, then I want to tell you that GPS DD is uncaught in this catch clause. And the reason is the data type inconsistent. Okay, because the throw is GPS DD, but the catch is JSON RPC CPP. Okay, so let's move here. But now we have the other piece of code, which is related to this piece of code, which is main function. And inside main, again, I have a try. And inside this try, I don't have any sorry, let me write down. Finish this writing first, and I'm catching a GPS DD. And of course, there's something inside here as well. Okay, but the important thing is inside the try clause, I actually indirectly call shadow GPS, set GPS label. Okay, so I didn't have any throw inside this. Let me actually make it with certain colors so I can I do this? Oh no, I don't want to do that. I want to do this. Okay, so essentially this particular line is actually called this function. And this function is actually throwing something which is uncallable by the layer of exceptional catch clause that's closest to, this is, by the way, is closest to the exception itself. So basically the exception handle here occur here, and then this is the closest catch clause to that exception. So that's the level one. But then that is because of the exceptional uh, type is mismatched. So this one didn't get it. So what it does in the C++ exceptional handling, it will propagate this to the higher level, which is the main function. And inside the main function, I do have a catch clause, which is I also modify such that it will catch GPS DD and such that it will be caught here. So that's why after I make that changes, make those things, first I change shadow GPS such that I'm actually causing the abort trap 6. But then I actually modify the main function to actually catch not in the level 1, but in the level 2. And then basically it still works. So there are a few things is that you have a different place you can catch. The other thing is sometimes you write a piece of code like this, And if you examine the code, there's nothing about throw, but then you still catch something. That means this particular catch clause is not only catching the exception within the same file, but actually within all the function that this try clause has included. Because within this example, shadow GPS label, they actually have that. This is related to this. And this particular example is actually catching the exception from the new, which is the malloc. For example, you actually allocate too much memory, which then you have a bad allocation. This is a standard exception. It has an exception in the like a malloc type of function that in your system. So you have to have this in order to catch this. If you don't have this, then it's going to be uncaught, abort trap 6. Okay, I'm going to stop here and I hope you all have a good weekend. I will see you Monday.